Welcome everyone to our SCIEX Biopharma vodcast. I'm Roxy.
And I'm Kerstin. And today we are going to uncover how scientists are rewriting the rules of analytical science for biopharma.
In today's episode, we're talking about gene editing, specifically on and off target effects of CRISPR-Cas9. We're here today with Chief Scientific Officer Hugo Gagnon from Allumiqs. Thanks for joining us, Hugo.
Thank you for having me in this podcast. Thank you very much.
All right, so we'd like to get to know you a little bit more. We're going to do a quick fire round and ask a couple questions. We'd like you to answer with the first thing that comes into your mind. Are you ready?
Yes, I am.
Okay. So if you were shrunk down to the size of a molecule, what would you be?
A protein, obviously.
That's a big one. As a scientist, would you say you're rather a gatherer or a hunter?
Hunter.
Time to pick some favorites. High resolution mass spec or triple quads?
Iris.
Hugo, for those who don't know, very high level, what is gene editing?
I'll go very basic. So it's the use of tools to go into the genome and then either introduce, delete, or modify some part of the genes. And it enables either correction or disabling of a gene by itself.
So then what challenges do the analytics of gene editing bring?
Well, for us, there's many levels of challenges. Well, one being, to do gene editing, you need to use most of the time viral vectors that are, if you think about, people struggling to characterize monoclonal antibodies and characterize ADCs, you're characterizing a full microorganism, kind of. So it's very complex. The host cell proteins gets to another level. It's not only protein, it's protein plus DNA or RNA or whatever you put into it. So it's much more complex. So at that level, and the other level is what it gives. So what's the outcome in the cell when it gets integrated? So this can go well most of the time, but you do have some off-target or undesired effects. And that's where we put a lot of efforts to actually have a nice workflow to see, is it on target? Is it off target? What those undesired effects, are they there? Is there some percentage of misintegration, things like that? So that's what we put our efforts on. And it could be challenging for people that are transitioning from small molecules, even from large molecules like antibodies, and going to that level of complexity.
Hugo, what do you see as the biggest challenge for gene therapy in terms of analytics for the future?
Well, we're mostly research. We're not much in the regulatory space, but my understanding is that, right now, the biggest challenge is mostly related to the regulatory agencies adapting to this. And this will happen with the experts in the field, the CROs of this word, that will, I think that the right word would be educate, show, make them understand how it's done and why it's done that way and why that's the new gold standard. I believe that there's a lot of good work going on around that, but I think that's the most challenging part. It's the regulatory and the safety part around it. Yeah.
Our series is titled Rewrite the Rules, as you can see. So we are thinking of rewriting the rules of science, of analytical science, meaning doing things differently in the lab with analytical tools on the cutting edge of technology. Do you have any examples what you are doing which fit that theme?
Well, if we speak about analytical science, the classical way of seeing it by the rules of the FDAs and all that stuff using mass spec is triple quad. Is doing a very robust ROG method to quantify a single molecule To do gene editing, well, forget the triple quad. You will never get anything with a triple quad. You need high-res. So we are kind of changing the type of instrument that are installed in the lab normally. It changed also how you work because it's different stability, different type of results, way much more data. And I think the key there is to be able to manage that data, to be able to extract the information rapidly, because on the triple quad it's pretty easy. You've got a readout. It's like a UV detector. You've got a single pinpoint and you can do your standard curve. With iris, well, yes, you can do that, but you got much more information in the background, what you do with that information. And I believe that's where we need to put our efforts, be able to extract all that information, be able to interpret it, be able to report it rapidly and in a simple way. So every lab scientist can have that report in hand and be able to understand it. So that's our goal.
Fantastic, thank you. Well, we want to thank you so much for joining us today, Hugo, and sharing your insights into the field of gene therapy.
Thank you very much.
And also to our viewers, thank you so much for listening in. If you want to know more about the application like gene editing or check out more workflows, please make sure to visit SCIEX.com and see you to our next episode. Thank you.